Alright, so today's video we are going to discuss the very last part of Trigo chapter already. Okay, so we are going to focus on the pattern of A cos theta plus B sin theta. Okay, so why do we need to have this part is because of just to show you an example, okay, a very simple example. Maybe in AS level, right, so maybe I show you like this. Okay, in AS level, when you face this kind of problem, like, okay, let's say they tell you 3 sine theta, okay, because our question using cos, so maybe I start with cos is better. Okay, so maybe I tell you that I'm having 3 cos theta, okay, minus 4 sine theta equals to 0. And if they want you to solve for the value of theta, so how can you solve it? Let's say they tell you that, okay, the theta must be between 0 until 360. Alright, so to solve this equation, generally what you learned before is that you can bring the sine theta over. Okay, and after that you're having 3 over 4, which is equals to sine theta over cos theta. And when you solve it, you have tangent theta equals to 3 over 4. Alright, then you find out the basic angle. Okay, what is the basic angle? And after that, you can get the value for the theta. Right, so this is solve it. This is what we learned it in AS before. Alright, so you can solve the equation when you're having A cos theta plus B sin theta. So the A and B can be any constant, any numbers. Alright, okay, then when we come to A2, if they slightly change the question, if let's say I tell you that, okay, I'm having 3 cos theta minus 4 sine theta, it is not equals to 0 anymore, but it is equals to a number, maybe a 1. And if they want you to solve it between 0 until 360 for the theta. Alright, so if you try, no matter how you try, you will realize that this kind of question you cannot solve it at all. Alright, by using the limited knowledge that we learned before. Okay, you cannot just become tangent because there must be some numbers disturbing you from solving the equation. Alright, so just a very simple number. If it is equal to 0, you can solve it by changing it into tangent. But now when they change the value into a 1 or whatsoever, right, any numbers are, okay, so you will realize that no matter how hard you try, right, even if you want to change it become tangent or any other identity and so on, actually you still cannot solve it. Alright, okay, therefore, for this pattern, okay, they realize that actually we can use the compound angle formula that we learned before, and then we can rephrase it into a compound angle formula. Alright, and then after that only you solve the equation. Alright, so this is why we need to have this part here. Alright, so for this, mainly we are going to change it, become the compound angle formula before you can solve the equation. Alright, okay, so that's the purpose that we have this session here, this part here. Okay, if you look at our notes, alright, our notes, it actually looks a bit, how can I say, it is a bit complicated, not to say complicated, right, but it is something that you should know, okay, the summary. When you are having A cos theta plus B sin theta, okay, and then if you want to change it, become a compound angle formula, okay, the easier method is you look at the cos here. If let's say the first term start with cos, then you change it to cos. Alright, and then if your first term start with sine, then you change it into sine. Sine, the compound angle for sine, compound angle formula for the sine. Okay, so this is the first thing that you need to know. Alright, and in our syllabus, all the questions so far that came up in partial series, they are all following this rule. So first term start with cos, you change it become cos. First term start with sine, then you change it become sine. Okay, and this is the first thing that you should know. And the second thing is when you are changing the cos, become the cos compound angle formula, then you have to take note on the sign. So if let's say you're having plus minus here, when you change become cos, the sign inside will be always opposite. So originally, if you are having a plus, when you want to change it become the cos, you will have negative inside. Okay, if you have negative outside, then when you want to change it become the compound angle for cos, then it will be positive inside. Okay, and then for sine, if you are changing it into the sine compound angle formula, then you follow the sign that you have. Okay, plus minus means plus minus. All right, and the pattern is always something like this: r cos theta negative plus alpha, or r sine theta plus negative alpha. So you'll see that there are two special symbol here. That means you don't know what is the r and what is the alpha. Okay, so how can you get r? So to get the r, actually it's very simple. You can actually straight away apply the formula r equals to square root a squared plus b squared. Okay, and when you want to get the value for alpha, alpha is equals to b over tangent inverse. All right, so actually in short, this is a formula which is important. Okay, you need to know what's the formula for r and what's the formula for tangent alpha. Okay, all right, so now, and then again, we will have the proving part. All right, but just to let you know the basic rules first, as what I said just now. So usually it will be easier if you have cos change to cos, then sine first term change to the compound angle formula for the sine. Okay, and then when you want to change it become the sine or cos compound angle formula, generally there are a few things that you need to know also. Okay, you know the formula for r, right? Okay, so please take note that you know r is always positive. There's no negative value for r. It must be always positive. That's the first thing that you need to know. And the second thing that you need to know is the alpha must be always in the first quadrant. Okay, so these two details are very important also. Alpha is always in the first quadrant, so that when they want you to calculate all the property, when they want you to calculate all the solution or answer, right, it is easier, much more easier for us to calculate. All right, and then the r is always positive is because of when you take square root here, okay, it is always considered only the positive sign. All right, there are some rules behind it. Okay, so how can we know these two rules? Actually, they can show it by using proof. All right, so in these notes, I already attached the proof for you. Okay, so as an example, your first step is you're having a cos theta plus b sine theta. Okay, and then as what I said, if you want to change it into the compound angle, because the first term start with cos, therefore it will be easier if you change it into cos. All right, okay, and then after that, you expand the compound angle formula for the cos, you will get this one. Okay, and please take note also okay, you see the sign are different one when you're having the cos. Okay, so after you expand it, and you can try to compare them. Okay, all right, so for me, I will use a simple example, okay, to show you the proving also. Okay, so let's say I'm having what is my example just now? 3 cos theta. Let's say I'm using minus here, so minus 4 sine theta. So when I want to change it into the compound angle formula, what am I doing here is I will let it become r cos theta plus alpha. So do you understand the rules or not? Because my first term is cos, therefore I will want to change it become the compound angle formula for the cos. All right, and then because here it's negative, when I'm having the cos compound angle formula, inside the sign will be different from what we have outside. Okay, all right, so I'm taking this as an example to show you that you can compare it with the proof also slowly. All right, so that you know the difference between them. Okay, then now for the left hand side, I just copy. All right, so when I expand cos theta plus alpha, I will have r cos theta cos alpha. Then what do I have? I'm having minus, because when you expand it will become minus, right? So r sine theta sine alpha. So I think now you should know what should I put the opposite sign here, so that when you expand it now you have a similar sign after you expand. Okay, all right, so this is what we have here. And then they try to ask you, okay, rephrase and ask you to compare the equation. So let's say I rephrase it a little bit. Okay, for my answer here, for my example here. Okay, so I maybe put r cos alpha together, and then I'm having cos theta. Okay, minus r sine alpha sine theta. Okay, so now I want you to compare left-hand side and right-hand side, and what can you see? Okay, so do you see anything here? All right, so first, I want you to have a look for this one. 3 is actually r cos theta. Can you see that? Because r cos alpha, sorry, cos theta and cos theta are the same thing, right? Okay, cos theta and cos theta should be the same. Therefore, r cos alpha should be equal to 3. All right, so I'm having r cos alpha equals to 3. And this is my first equation. Okay, and after that, what do I have? So if you compare it again for the sine theta term, so for sine theta, you will see that negative, maybe 4. 4 is actually similar with r sine alpha. Sine theta is sine theta, right? So r sine alpha, if you compare, it will be equals to 4. That's why you should have r sine alpha, which is equals to 4. So you have two equations here, and generally you can form, okay, you can solve the equation simultaneously to get the answer. Okay, so how to solve it simultaneously? Okay, so when you're having two equations like this, then you can do equation number 1, you square it, plus equation number 2, you square it. So equation number 1, when you square it, you are having r square cos square alpha. Okay, then plus, okay, wait, should I follow the steps here? Okay, so I'm using 1 square plus 2 square. Okay, so from here you will see that first equation when I square it, I'm having r square cos square alpha plus the equation number 2 is r square sine square alpha equals to right hand side. So right hand side you are having 3 square plus 4 square. Okay, and then you try to factorize the r out. Okay, so when you try to factorize the r, you have r square, then cos square alpha plus sine square alpha. It is equals to 3 square plus 4 square. Okay, so this whole thing is equals to, right? Okay, so this is equals to 1. That's why on the right, you should have only r square equals to 3 square plus 4 square. And therefore, your r is square root 3 square plus 4 square. So for this case, we are having 5. If let's say I really want to get an answer. Okay, but when for the proving part, you will see that this is how they derive the formula. R equals to square root a square plus b square. Okay, so in exam, when they want to solve this one, you don't need to show the detailed steps like what I show you here. We can show you apply the formula. Okay, so I show you here, just that I want you to really remember and know how to compare, how to get the answer, how to get the equation. Oh, sorry, how to get this formula. All right. Okay, so you know the R already. So the R formula is this one, which is very important. Try to memorize it. Okay, then how can I get the alpha? So to get the alpha, I want to get rid of the R first. So to get rid of the R, they are using 2 divided by 1. So I'm applying the same thing here. I will take 2 divided by 1. So when I take equation number 2 divided by equation number 1, what do I have? You should have r sine theta divided by r cos alpha, sorry, r sine alpha divided by r cos alpha, which is equals to 4 over 3. Okay, so if you continue to simplify it, you will have tangent alpha equals to 4 over 3. So you can actually get the value of alpha by taking tangent inverse 4 over 3, and eventually you will get the value for alpha if you want to continue. All right, so for the proving part, they only show until you get this. You get tangent alpha equals to b over a, and therefore this is the formula for the alpha. In the exam, you can still apply the formula. So for the proving part, we just want to show you. Why I want to show you this proving part is because of you can see it clearer. All right, because this comparison is very straightforward. So you should know that R is actually what value and alpha is actually what value. Okay, so if you have a look here, If you compare it with our equation, then you should know that 4 is our B. This one is a B, and this one is A. All right. How they decide it? Because they will do this as a A, and this is the B, without referring to the sign. They only look at the magnitude of A and B. Okay or not? All right. So in short, what you need to do is you need to remember the formula for R, which is square root A square plus B square, and R must be always positive. And the second thing is tangent alpha equals to B divided by A. And then alpha is equals to tangent inverse B over A. Okay, therefore the alpha is equals to tangent inverse B over A. All right, and alpha is in the first quadrant. Okay, so this is what we have. All right, and after that, if you, because just now I say, if your first term start with cos, let's say 3 cos theta minus 4 sine theta, right? Then you change it become cos is easier, correct or not? Okay, how about if let's say the question now, they give you 3 cos theta minus 4 sine theta, but they want you to change it become sine, then how? Okay, so if they want you to change it become the sign, what you need to do is that you just make this opposite. That means you bring the negative 4, or maybe plus is better. Okay, so you have positive 4 sine theta plus 3 cos theta. Then you change it become r sine theta, theta plus alpha. Okay, if let's say you are having the first term is the cos, and then they want you to change it become sine. So this is what you do. You exchange the sequence of the sine and cos. And therefore you have first term is a sine, then you change become the sine cos-angle formula. Alright, so this is some small details that you need to know before we start applying this formula. Alright. Okay, so for this video, we'll stop here. And then for the next video, only we are going to discuss how can we apply all this formula from this part and how to solve the equation that involve on this. All right. Okay, so we'll see you again in this in next video.